Okay, welcome again, everybody. My name is Christina Medved. I'm the Director of Community Outreach with Roaring Fork Conservancy, and it is great to see so many of you here. We have people here from all over the state of Colorado, so welcome. We have a lot of new names here tonight, both to Roaring Fork Conservancy and to Aspen Global Change Institute. So if you wouldn't mind sending me a little note in the chat box, let us know how you heard about tonight, whether it was through one of our social media platforms, whether it was through our newsletter, our website. That just helps us with promoting presentations like this in the future. So just as a quick reminder for those of you just hopping on, this presentation is being recorded tonight, and I will be emailing everybody a link to where you could find this presentation tomorrow. So before I turn the evening over to Elise, I wanted to go ahead and just give everybody a very brief overview on who Roaring Fork Conservancy is, because we do have people here from all over the state. And so I'm just going to give you a quick little introduction, a little tease, if you will, and then you can obviously find out more about us on our website. So give me a moment here to get situated. Hopefully everybody can see that okay. Elise, can you give me a nod if that looks okay? Great. Okay, so for everybody, Roaring Fork Conservancy is located in Colorado on the western slope of Colorado, and this little blue section here is the Roaring Fork Watershed. We don't look like a very big watershed, and we're not actually. We're only about 1,400 square miles, but roughly about the size of the state of Rhode Island. But we are a very important tributary to the Colorado River, and it's mostly because of our really high mountains. We have 7 14ers in our watershed that can hold on to snow well into the spring and summer on good years. And contributes quite a bit of water to the Colorado River, helping feed 40 million people in the American West. And as you may or may not know, snow makes up about 80% of the water supply here in Colorado. So we are actually in our 25th year as the watershed organization for the Roaring Fork Valley. And our mission is really simple, but fun. Also, we want to inspire people to explore, value, and protect the Roaring Fork watershed. And we do that primarily through our watershed science and policy programs and our watershed education programs. So our science programming includes everything from stream monitoring and targeted studies. Our policy work utilizes that scientific information to work and engage with stakeholders throughout the watershed to come up with solutions to help improve our rivers and streams. And then our education programs reach over 5,000 individuals every year. And that covers everything from kindergarten through college age programming, and also adult and family programming. And this is an example of one of our adult programs. Feel free to learn a lot more about who we are and our education programs on our website. So let me go ahead and proceed here. Okay, so just a quick tour of our watershed. So this blue pin, if you will, near Independence Pass is where the Roaring Fork River begins. So the Roaring Fork River begins there, and it flows through the city of Aspen. It flows through Basalt, where it has the confluence with the Frying Pan River. And then once the Roaring Fork River gets to Carbondale, it has a confluence with the Crystal River. And the Roaring Fork River, this dark blue, flows about 75 miles before it reaches the Colorado River in Glenwood Springs. So our 3 major rivers in this watershed all begin in designated wilderness areas. So we have a lot of forested areas here. We have a lot of really good water quality here, and it's primarily because of our forested headwaters. In addition to being known for our gold medal fishing rivers and our beautiful lakes and our hot springs, we are also home to one of the most photographed mountain ranges in North America, the Maroon Bells. So if you haven't been here yet and you're from another part of the state or out of state, please make sure you stop by here in Basalt to come visit us when you come through. We'd love to see you. So tonight, we're excited to have Elise join us, and you'll see that there's a little addition here to the bottom of the slide, the Berkshire Watershed Institute. In 2018, when we moved into our new facility here in Basalt, we developed the Berkshire Watershed Institute. Pardon me, it was in 2019 that we developed the Institute. And the whole premise about it was to invite water leaders to present on local, regional, national water issues, but to ensure that like the public, like yourselves, have an opportunity to dialogue with water leaders one-on-one. And so tonight it will be Elise presenting a PowerPoint presentation and sharing with you the work that she does on measuring soil moisture to understand a changing water supply, but there will be opportunities for us to dialogue with Elise. So if you do have a question tonight, I ask you to please drop it in the chat box. Elise has also built in several opportunities throughout her slideshow to take questions, and but it's still best for you to type those in as necessary. I'll go ahead and interrupt Elise. There might be an opportunity if we need further clarification on your questions. We'll ask you to unmute yourself. But yeah, so if you have any other questions, regardless whether it's about tonight or something else, drop it in the chat box. I'll be monitoring it, and then we'll go from there. Sound good? Great. So I'm going to go ahead and stop my share screen, but I do want to ask everybody to hang on to the very end because I have a really exciting upcoming opportunity for everybody. You guys are the first ones to hear about it, and there's limited capacity on how many people we could bring. So please wait until the very end so we can tell you what neat opportunity we have for you. So while Elise is getting her her presentation ready to go, I want to go ahead and introduce you to Elise. So Elise Osenga is the Community Science Manager for the Aspen Global Change Institute, a nonprofit that has been a part of the Roaring Fork community since 1989. Elise manages the organization's long-term research network, hosts their fieldwork internship program, and helps to coordinate partnerships locally and across watersheds. Elise comes from a background rooted in fascination with the natural world and a passion for effective communication. Prior to her current position, she has worked as an environmental educator on the South Platte River and as a science writer for earthdesign.org. And you worked here at the Conservancy too for a little bit. So I wanted to make a little plug for that. Elise holds a BA in biology and English from St. Olaf College and an MA in conservation biology from Miami University in Ohio. So I'm going to go ahead and turn the evening over to Elise, but I just want to let you guys know, just wrapping it all into introducing you to our small watershed that we have here. We might have a small watershed, but it is a vital watershed. And so there is a lot of really good work happening here. And we are going to let you know at the end how you can help participate in some of that work. So Elise, thanks so much for being here tonight. I'm going to go ahead and mute myself, and the microphone is yours.
Great, thanks so much, Christina. Well, I'd like to start by thanking the Roaring Fork Conservancy for inviting me to talk to all of you guys today about how soil moisture can help us better understand our water supply. Before I jump in, I do want to give a quick overview of the Aspen Global Change Institute, as this might be an organization that's new to some of you. We are a small nonprofit that's dedicated to advancing global change science and solutions. And we do this by work in three primary overlapping areas. One is that we work to nurture community. So this typically means getting scientists to talk to other scientists, which doesn't sound that hard, but a lot of times people in one field can get really narrow in their focus. And that can be to the detriment of answering some really difficult questions. So it might be researchers across different earth sciences, or it might be even getting some earth science folks to talk to some social scientists. And then we work to advance the science. So sometimes that means identifying gaps in understanding or in data. Sometimes that means collecting the data ourselves. That can be a really varied approach. And then the final circle, catalyzing solutions, is one that really exists because of its links to the other two. So what we mean by that is getting these multi-way conversations going between researchers and the people who need to use that information, whether that's resource managers or the public, and having that be not just here's a bunch of data, go use it, but facilitating real conversations and real collaborations. So there's an actual understanding of where the societal needs are for certain types of science and what the questions out there are. And the project I'm going to talk to you about today that ties into soil moisture is one that actually really exemplifies all three of those circles. So that project is the Interactive Roaring Fork Observation Network, or IRON. This is a program that provides long-term data collection that can be used for research, outreach, and partnerships. It's a community-driven project. From the beginning, this is a program that has been financially supported by the county, the city, and other local organizations, and one in which those resource managers have helped provide research directions, and where we continually are checking in to make sure that the work we're doing is going to be valuable to the community we're working in. But it's also a program that we see as having value outside of our basin as well. And so we're currently in the process working on gaining some partnerships in other locations as well. and trying to figure out how the information we're gathering right here can help other mountain watersheds better understand hydrology and ecology in their own spaces. And this is something that we're interested both within Colorado and even at an international level as well. So the overarching mission that ties all those bits and pieces together for the Roaring Fork Observation Network is a desire to advance understanding of mountain hydrology, ecology, and how those tie into climate change by building community among researchers and data users and across watersheds, and providing decision-relevant data to manage people who are doing resource management. And all of this is happening in the context of climate change. And so next I want to move into a couple questions. Why does long-term research and soil moisture research matter, and why here? I can really abridge the why here version because I think Christina covered that really nicely. As she mentioned, the Roaring Fork watershed is actually a really major headwaters for the Colorado River. So we're not only providing water all the way out to California, we're also actually providing water the other direction too. So if you're on the western slope and you are someone who gets water from the South Platte, some of that water actually originated here. It got pumped up and over the Continental Divide. So this is really a critical watershed, whichever direction you are from us in Colorado. So I want to jump to the really big picture here, which is, what does climate change mean for the Colorado River Basin as a whole? And why do we need to have data collection like this still happening? So to do this, I want to reference a report that's a really great report, great in terms of being really high quality, not in terms of good news. It's actually all pretty much bad news, but it's really well done. The Western Water Assessment put out in 2020, the Colorado River Basin, the Colorado River Basin Climate and Hydrology State of the Science Report. And this is a report that basically looks out and says, what are the data we have? What are the model and forecasts we have? What are they telling us? And where are there opportunities that can be met to better understand what's happening in the Colorado River Basin? And I pulled a couple key points out of this report. The first is probably not a surprise to anyone. The Colorado River Basin currently faces unprecedented stresses. Surprise! So the component that follows along with this, though, which I've paraphrased instead of pulling as a direct quote, is one that I think is really important. Our ability to model and to prepare for these challenges is dependent on the data sets we use to create them. Your models are only as good as your data, and your ability to prepare for the future is only as good as your capacity to understand what's happening. And building off of that, I have another quote: unless average basin precipitation increases substantially, system runoff and water supply are expected to decline over the next several decades due to warming alone. So in other words, understanding the impacts of the warming temperatures associated with climate change is a really key piece in building ourselves the right tools to prepare for and address these future water issues. So I want to unpack that last quote a little bit. Why is temperature such an important thing when we're talking about water? So this is a graph from the National Oceanic and Atmospheric Administration that shows observations of total rain and snow, so total precipitation in Colorado dating back to 1895. And in Colorado, you get really wet years, you get really dry years. There's a huge variation from year to year. But if we look back over the past 100 years or so, there isn't a clear trend. It isn't continuously drier or continuously wetter. We're in a really bad drought period right now, but there have also been bad drought periods in the past. What's different is the temperature. So looking again at another NOAA graph, going back to 1895, again, these are observations of Colorado average temperatures annually. And there is a trend here. What we see is that Colorado is getting warmer. And this is a trend that is expected to continue. And this really matters because temperature ties into drought very closely. So among the reports that came out last year was a NOAA Drought Task Force report on the southwestern drought that we are currently in. And they had some pretty interesting findings in this report. I shamelessly stole this slide, by the way, from Brad Udall, who gave an excellent presentation on this back in October that is available on YouTube if you want to dive in more deeply. So this report found that the 20-month period between January 2020 and August 2021 had the lowest total precipitation since 1895, the third highest daily average temperature since 1895, and a record high vapor pressure deficit. And vapor pressure deficit is basically just a way of saying how thirsty is the air, how ready is it to take up water. But what was really interesting is that what they came to conclude was that the low precipitation appears largely natural. So what that means is we have years in Colorado, we have decades in Colorado where not that much water falls out of the sky. But what made this more recent drought that we're currently in different is that warm temperatures have exacerbated that drought. And this is important because warm temperatures that help make this drought so intense and widespread will continue and increase until stringent climate mitigation is pursued. So in other words, warm temperatures make drought worse. So why is temperature such a big deal? I'm sure some of you think about the water cycle on a daily basis. Others of you might not have thought about the water cycle since maybe 4th grade. So I wanted to make sure we're all on the same page as we move forward in this conversation. This is a very basic diagram of the water cycle. So it's basically anywhere in the Earth system that water is transferring from being into a new place. So you have water coming out of the sky as rain or snow. Some of that forms snowpack, some of it might run off immediately. Some of it goes into the ground. And soil moisture then becomes this middleman, this almost banker between what's happening with everyone else. So some of the water that goes into the soil gets taken up and just hangs out there. Some of that water moves down and recharges our groundwater supplies and our aquifers. And some of that water is lost back to the atmosphere again, either through transpiration, where plants open their leaves to breathe and lose water back to the air, or evaporation, where the water is moving from being a liquid in the ground to being a gas in the air directly. And a lot of times in science, they'll combine those two together into one blob and call it evapotranspiration. So that's all the water getting lost back to the air, whether or not it goes through a plant first. And that's where temperature comes in. Warmer, drier air takes up more water. And this becomes particularly important if you're seeing warmer temperatures happening and you're already in a drought situation. So soil moisture is then this really important player when you're trying to figure out what's the difference between the water I'm seeing in my stream and the water that's getting lost back to the air. So I'm going to dive in a little bit deeper now into what is soil moisture. So it's the amount of water held in the soil at any given time. And as we just covered when we were looking at the water cycle, it's this important distributor between what's happening in the air, the ground, the streams, and the plants. That means it also is really important in a lot of other things. It's important in plant survival. It regulates near ground temperatures. It helps us understand flood and fire risk. And then the final two components that I'm going to talk about more later in this presentation, it influences how much snowmelt ends up in our rivers. And it creates this memory from year to year when you have a drought. So here is how soil moisture connects one year to another year. Essentially, it is a giant sponge. So kudos to my intern this summer, Hiromi Kondo, who made this great little graphic for us to show how soil connects across years. So if you picture a sponge, it can take up a lot of water, but it also hits a point where it's not going to take up anymore. And the same is true for our soils. So quick caveat, this graphic here applies really only to places where the ground freezes in the winter and where there's snow. So if you're somewhere lower elevation where your snow is repeatedly melting out and your ground maybe doesn't freeze, this doesn't quite apply to you. Soil moisture is going to behave a little bit differently where you are. But up here in the mountains, what happens is in the fall, you have a certain amount of water in your soil, and then the soil freezes. And so that water is locked in all winter long. That's not really going to change. Over the winter, the snow builds up and makes a snowpack. We're hoping for a nice big one this year, fingers crossed. And then in the spring, the sun comes out, the snow melts, and some of that snow runs off, but some of it gets taken up by the soil. And how much water you had back in the fall determines how much water can still be taken up in the spring. So if you have a really dry soil going into winter, when the snow starts to melt, you're not going to have as much runoff because it took up so much water. There was so much space to take up water. Whereas if you had a really wet soil going into winter, you're going to have a much bigger runoff from the same amount of snow because the soil can't take up as much. And so this gives me something in common with Paul Hollywood of the Great British Bake Off. I am frequently asking, are you sure your sponge is going to be moist enough? And that's the question we're all asking going into this winter, because last year we saw what happened when the sponge is dry. So caveat about this table before I take you through the numbers. This is a quick and dirty set of numbers. I did not do anything fancy to get here. It's meant for a quick mind exercise to illustrate what I'm talking about with that sponge situation. So what I did is I took 2 years, 2013 and 2021. And both of these years had below average snowpack at the SNOTEL sites where they're measuring snow in the Roaring Fork watershed. In 2013, it was about at 77%. At 2021, it was at 79%. So not the full snowpack we would want to see. But going into those 2 years, the fall conditions looked very different. So at one of our sites, the Sky Mountain site, we had a volumetric water content in our soils of 0.27. I'm going to talk a little bit more about what those units mean later on, but for now, just know at this site, 0.35 is about as much water as the soil can hold, and 0 is I stuck it in an oven and baked it. So a 0.27 water content is actually pretty wet for this specific site. And what we saw in 2013 was at the Roaring Fork River at Glenwood Springs, the peak discharge reached 10,300 CFS that summer. That was the highest flow we saw in the river that year. Now in 2021, going into that year, the water content in the soil was less. It was only 0.2, and that's a pretty decent difference between 0.27 and 0.2 at this site. And what we saw in terms of peak discharge at the Roaring Fork, it never got above 6,760 cubic feet per second last year. So we had really low water levels in our rivers. I will put a small caveat in. There's of course a lot of factors that influence it, but soil moisture is one of them. And so what we see here is that although snowpack generates most of our water supply, soil moisture can carry this memory of a drought from one year into the following year. 2020 was really dry, and consequently 2021 saw really low runoffs. And it also creates this link to air temperature. So if you know soil moisture is influencing what's happening in terms of your stream flow, then that means that air temperature where you're causing more evaporation from the soils is going to be then tied in via the soil to what you see in terms of stream flow. It also is a tie-in to when we get our rain. And it matters if we get our precipitation in June versus if we get precipitation in October versus if it's spread out across them all. Because what we're looking for if we're thinking about next year's water is late October, early November. Are we getting the big rainstorm that we typically do get in the Roaring Fork watershed that's going to help recharge those soils going into winter? So I want to pause before I carry on and talk a little bit more specifically about our stations and how they measure soil moisture, and just see if there's any questions about those previous slides that I should cover before I move on.
Elise, I do not have any questions in the chat box for you at this time.
Okay, there will be further opportunities for questions later.
Okay.
All right, so this is what one of my stations typically looks like. So it's a little tower out there, and we're measuring both weather parameters as well as soil moisture, because of course, I talked earlier about that relationship between warm temperatures and what's happening elsewhere. So we want to make sure we have that background information to give us a context for what we see in the soil. So to just walk you through the different parts of this station, I think you should be able to see my mouse. This is a solar panel. It powers the whole station. This is the logger box. It collects data about every 20 minutes and sends it via cell phone signal to the internet about every 4 hours. And some of our stations don't have cell phone connections, so they look a little bit different because they have a satellite-based box instead. In terms of what we're measuring, we have a tipping bucket rain gauge, so that looks at the amount of rain that happens throughout the summer. We're measuring relative humidity and air temperature, and then underground, we have soil moisture sensors at 2, 8, and 20 inches, and a soil temperature sensor at an 8-inch depth. And some of our sites also are able to measure snow depth or wind speed. We even have one that measures radiative balance. So that's looking at how much reflection you get from the snow. So we can hopefully go back and start to look at things like dust on snow events at some point in time. And we have 10 of these stations. I'll show you where they're located in just a minute. The oldest station went in 2012, so it's coming up on its 10th birthday. And the most recent station went in 2020. If you are just perishingly curious about what type of instrumentation we use, that link at the bottom of this slide is to a paper we put out, just a short 2-page white paper that went out last year that gives a full description of the type of equipment we use and where you can find the data, because it's all publicly available. So this is where our sites are located. They really run the gamut of the Roaring Fork watershed, from near the confluence with the Colorado River all the way up to Independence Pass, pretty close to the Continental Divide. And we selected these sites for a couple of different purposes. We wanted to make sure we were representing the different major ecosystem types and land uses here in the Roaring Fork watershed. We wanted to have that elevational gradient, because how climate change influences systems varies quite a bit at lower versus higher elevations. And then finally, in a really practical way, we wanted to make sure we were located on lands that we could access to put the sites in and that we had actual permission to use. So most of our sites are on public land. A lot of them are on county land. We have one on city property down in Glenwood Springs, and one that's actually on a private property with a landowner who is really interested in supporting this situation. This is just another way to think about our stations, that they cover these very different ecosystem areas within, as the crow flies, a pretty close geographic proximity, but in terms of distance from sea level, a pretty wide span. So how our measurements work is we have these sensors called dielectric sensors. So I'm going to stop sharing for just a minute here. This is what one of our dielectric sensors looks like. So essentially, the way this measures soil moisture is it sends a very small signal from one tine to the other, and the speed at which it travels lets the sensor know how much water is in the soil. And you might be thinking, well, soils have different salinity, they have different textures, wouldn't that matter? And the answer is yes, these show up pretty well calibrated, but before I stick them in the field, I do a calibration with soil collected from the site where this is going to be deployed to make them a little bit more accurate. So if it's in clay, I know how it behaves in clay versus in a different type of soil. So this is what our deeper sensors look like. Our shallower sensors are a little bit smaller because if you're only 2 inches underground, you don't want to be sending out quite as broad of a signal, you might confuse it. So how is soil moisture measured? I did promise I would explain to you guys what volumetric water content is. That's not how everybody measures soil moisture, but if you're out in the field with an in situ, so a site that's physically on the ground, this is a pretty common unit of measurement. And so volumetric water content basically is, if you filled a jar with a known volume of soil, how much of that is actual physical soil and how much of that is water. So 0 volumetric water content means there's no water at all. You took that soil and you baked it in an oven, it has no water left to give. 100% would be if I just stuck one of my sensors in a glass of water. 100% is pure water, there is no soil involved. So most of our soils top out around 30 to 40%. Some of them are able to take up a little bit more water, but that's the point at which you're going to start to just see standing water on the ground, that they just cannot take up any more water. So when I'm talking about units and I'm saying 0.3 or 0.4, that's why 0.3 or 0.4 is actually a very wet soil, is because that's the point where it stops being able to fit more water in between its pores. Before I dig into the graphs, I wanted to just pause again in case there were any questions about how we're measuring soil moisture.
I do not have any questions for you yet in the chat box, Elise.
All right, we'll dive right into the graphs then.
Okay.
So I wanted to start when I shared my data by giving you a picture of what a year looks like in the life of soil moisture. So this graph shows 2, 8, and 20-inch depths all at the same site for the year 2019. So what you're looking at is each line is showing the daily average value of soil moisture for that date at whatever depth the line is. And this particular site is Sky Mountain, which is a nice site because it has a loam soil. So that means it doesn't hang onto the water super tightly. The water does not run through too quickly. So we get kind of a nice general look at what's happening. So in January, not much happens exciting for the soil moisture. The ground is frozen, the moisture doesn't really change. Then come along March or April, the ground starts to thaw and the snow starts to melt at this site. And so what you see is soil moisture starts shooting way up as the ground is taking in more water. Then along the middle of spring, May, June, our soil moisture starts to peak for the year. And typically peak soil moisture at an 8-inch depth tends to tie into around the date when snow is disappearing off the ground. So what that means is once you've hit peak, things start to dry pretty quickly. And if I had the 2-inch depth up, you maybe would see more of those rainstorms in June and July if we had them, because those 2-inch soils will show a little bit more of those daily rain events. But down at 8 inches in the ground, it takes a really pretty heavy rain event, usually at this particular site, about a ½ inch or more of rain in a day in order for that water to start to penetrate down to 8 or 20 inches. So you see this gold line, that's our 2-inch depth. And you see here we have some bumps for rain events and some smaller bumps for smaller rain events. And then here in October, November, that big rainstorm that we hope will happen to help recharge the soils going into winter. Although we actually ended up having pretty rapid drying at the shallow depths. Then our 8-inch depth, I don't know why my key is showing it as brown, but our 8-inch depth is purple. So the next lightest line after yellow. You see a similar pattern. We have soils are frozen in the winter, snow melt and soil thawing leads to a lot of wetting, soils are nice and wet, and then they dry out. And you'll see a little bit of movement when we get those really big rain events. And this October-November storm recharged our 8-inch soils nicely. But for 20 inches, it takes a really heavy rain event or something as intense as snow melt to really change that soil moisture very much once it starts drying. So this is, yeah.
Elise, do you mind if I just jump in for just a quick moment?
Yeah.
Jacob Mikula had a good question. He asked, how does the timing of, and I'm sorry if you were going to just get to this, so let me know. How does the timing of peak soil moisture compare to local peak stream flow? Were you going to address that?
I was not, and I apologize because I am not prepared to answer that question. I have not pulled all my data out.
No, that's okay. But I think just looking at your graph, one of the things I can add to this just real quick is typically the peak runoff in the Roaring Fork River is beginning of June. Historically is the beginning of June. So that's all I will add.
Thank you. That's really helpful, Christina. So it seems like then what would happen is about what you'd expect, that you'd see the snow finish melting out, and that would be right around when peak stream flow would happen, depending on how close you are to the river. This might tie a little bit into that question. So date of snowmelt varies quite a bit from year to year up here. I'm using the term snowmelt loosely because this is not a site that has a snow depth sensor at it. I should have thrown my Independence Pass Station snow in, but there's time for that later if we have time at the end. But what you can see is a year like 2013, you might see that peak happen later. A year like 2015, it happened earlier. And you also can see, just comparing these 3 years, 2013, 2015, and 2020, how very different that start value of soil moisture can be. So I would love to overlay this graph. I wish I thought of this morning with stream flows from 2013, 2015, and 2020, because I think you would probably see a pretty clear relationship in stream discharge between a year like 2015, where we started with really wet soils, versus a year like 2013, where we started with really dry soils, depending on if the snowpacks were similar. An important thing to remember is that each of these sites that I have are best compared to themselves unless you do some fancy things to make the data appropriate to compare across sites. So what I mean by that is that soil behaves really differently with water. So for example, if you have a clay soil, it hangs onto the water really tightly. So this is our Brush Creek site, and it's a highly compacted clay soil that is an area that was formerly grazed and is currently getting restored by Pitkin County Open Space and Trails to be a sagebrush landscape. And you can compare this to another site that's not that far down the road if you're a crow and flying directly from spot to spot, where up on Smuggler Mountain, the soil's this loam that is basically a sieve. Like we have a rainstorm and the water just drops down through 2, 8, and 20 inches and just disappears. And so when I'm thinking about soil moisture from different sites, that's something important to keep in mind if I'm just looking at volumetric water content as opposed to a different type of way of looking at soil moisture. So Brush Creek, where it's a clay soil, in 2020, it just sat around between 0.25 and 0.2 the entire summer. And that might sound really wet, but if you're a plant, that's actually not all that helpful because you're working so hard to get that water out of the soil. Versus somewhere like Smuggler Mountain, where it sat between 0.15 and 0.7 for that same summer, that's a pretty typical behavior for a loose loam like that. And so although that is dry and there isn't a lot of water there, plants probably aren't working as hard to pull that water out. And if I'm thinking about something in terms of how does this year compare to last year, I'd want to look at Smuggler Mountain compared to Smuggler Mountain, again, unless I've done something like looking at distance from saturation or something like that as a way to make it more comparable across sites. Quick pause for questions before we jump to comparing 2020 to 2021.
Okay, we have a question. We have a couple of questions from Hillary. Do you try to keep the slope at each site similar?
That is a great question, Hillary. So there's this kind of tension in the research community between you want to have sites that are all the same so you can compare them really well, and you want to have sites that are realistic to conditions because that's representing what's actually happening on the ground. And so this was an issue that in some ways was sort of resolved for us because so much of the land up here is national forest land or wilderness. Those are areas we can't put a shovel in the ground. So we were a little bit limited in our site selection. And so we ended up really picking based on, is this the ecosystem we want? Is this a different soil type than we already have? Is this an accessible place? But that's not how everyone does it. So some of our sites are totally flat. Some of our sites are sloped. And that's something that anytime we report our data to someone else, we want to make sure we have that metadata available to them so they know if they're looking at a slope or a flat ground or something like that. And it's, like I said, there's kind of benefits to each way. So like SNOTEL sites that measure snow up across the nation, they typically have very specific parameters of like, do they want the ground to be level? Maybe they want the station in trees so the wind isn't blowing the snow around and they aren't getting their equipment blown out. And that's really great because then you can compare these sites to each other to a certain degree. Our sites don't necessarily do that, but that may actually end up being in our favor when we start to use these data in different ways. So one of the ways we're hoping to have our data used in the future is as kind of a sounding board for other remotely sensed forms of soil moisture data. So I will show a graph at the end about how satellites collect soil moisture data. And right now, satellites really struggle with areas that don't have flat terrain. So mountainous areas or highly forested areas. And so we're hoping that at some point we can find the right partners to start using our data for validation and saying, does this measurement match up with what we're seeing on the ground? And for a circumstance like that, it's actually really helpful to have sites that aren't perfect or aren't pretty, because that's a site that you might not already have data on, but it's a real situation where you have a slope or where you have trees covering your site.
Great. Okay, you ready? Next question.
Yes.
This is from Will. Is there a rainfall rate where soil can't absorb moisture and those intense rains just run off or flood?
There is. Out in the world, that is a real thing. Particularly, I know it's a big issue in like areas that have burned where you start to get soils that are just so hardened they can't take up that water. it is not something that I have experienced with my sites within my data record, but that is something that can happen.
Okay.
I hope that answers Will's question.
I was actually going to ask you a similar question on whether those torrential storms we had last fall, if you guys were able to monitor even if there was any shallow infiltration, because what we're seeing is such an intense rainfall that the slope just gives out. And so it doesn't really do much. What we're hearing is that it doesn't really do much to help with the soil moisture, but I didn't know if you had any data on that as well. So thanks for the question, Will and Elise. Are you ready? We have a couple more questions.
Yes, I will say this is a really, really great question, particularly Christina asking about that specific event that we had last fall. And if this is something where someone cares enough, they would like to follow up, I will probably be looking back at my data being like, oh yeah, what exactly did we see? So my information is going to be at the end of this presentation. I do encourage people, please email me if you really want to know, because I'm going to be digging into these things, and I would love to have someone who actually cares hear about that once it's done.
Yeah, and you know what I think would be interesting is because, we do hear a lot about what happens in areas that are burned, and there's still so much information we know, but also don't know. And so, it would be interesting to see in some of these natural sites what's been happening as well, right? So not a burn scar, but just in one of these sites that you're monitoring. Now, just real quick, I'm going to add this, but we don't have to do anything with this information until maybe the very end. It might be kind of a fun opportunity to dialogue, but Nathan, I think you're still on here. Nathan is a soil scientist in New Zealand, and he's on this call, everybody. I think that's pretty fun.
Wow.
He has some roots in Glenwood Springs. And so maybe at the very end, he can, when we have some discussion, he can share, maybe he has some information on some of the work that they've done in New Zealand.
That would be great. And I also would like to put out there, not just for Nathan, but anyone on this call, if you have experience in this type of things and you would like to answer a question in the chat, please feel free to do that. I should clarify, I am a field scientist and I have been working with these stations for quite a while, but I am not a soil scientist by training. And I'm not actually a hydrologist by training. So a lot of what I've learned has been on the job. So if there's a question you know how to dig into, please do that. Please jump in.
Great, thanks, Elise. I was actually going to add the same thing. So great.
Great.
Okay, we have a couple more questions. And I don't know who this is from. Why were there gaps in the line graphs?
That is a good question. The gaps are basically something went wrong. So you might remember, I'll jump back really fast. The very start of my presentation, I have this picture of a bear playing with our station, which is my all-time favorite picture from any of our stations ever. But sometimes things go wrong. So that bear actually caused a data gap in our rain gauge because it knocked it over. Not at this time, but at another time. At other sites, we've had rodents eat the wires. I wrap them all with reflective tape, but somehow, there's just this moment when the voles at Brush Creek were simultaneously all like, let's go for it. We've never touched the wires before, but we're going to eat them all in the course of the next week. And so I have missing data between when they ate through those soil moisture sensors and when I was able to get out there and replace the sensors. Sometimes it's a lot less exciting than that. It's a sensor goes awry and you don't know why. And sensors particularly love to do this when they know I can't get out in the field the next day, or it's a piece that I don't happen to have in my back stock of things I can just get out and replace immediately. Okay, great questions.
Yeah, these are great questions. Yeah. Okay, so I have a question for you from Sammy. And this will be the last question unless somebody else asks another one, but this is the last one that I have in the chat box. Do you have ground cover and or compaction data for these sites also?
The ground cover, my guess is I'm guessing Sammy probably knows a lot more about this. So the ground cover isn't specific to this is exactly what's sitting directly above my sensors, but we are doing vegetation surveys typically between every 3 and every 5 years at these sites. So we have a good sense of what the vegetation vegetation abundance and diversity is at each of these sites. I certainly do have in my loose handwritten notes of this is grass, this is the Smuggler Mountain site has really thick duff, which is the buildup of pine needles and dead tree matter and stuff. And in terms of compaction, no, it is one of my goals to get out there and work with a soil scientist who is an expert in this to get really specific, detailed data beyond just the simple data we have on soil type. And we did actually have a volunteer, Ryan Sparhawk, who came out and helped us with the Brush Creek site and got us some really great soil data on that.
Great, thank you.
Okay, great. So I'm nearing the final stretch here. But thank you for these great questions. As they keep coming up, please throw them out there. So I know for me, at least, I'm always really curious about last year was so terrible. It was in many ways a wake up year in terms of caring more about soil moisture. I know at the start of 2021, I got several calls from different folks in the press who all of a sudden were interested in soil moisture because we had these really low runoffs that happened at the start of spring for us. And so I've had a lot of folks just ask me, how does 2022 compare? And this graph is not completely updated because it's been a busy start to the year. But looking at December as we were heading into winter where those soils were going to freeze at an 8-inch depth, what I found was summarized as this. Some of our sites, our soils were a little bit drier heading into winter than they were in 2020, which is really bad news. Other sites, they were wetter than they had been in 2020, and some sites, they were about the same. So it was variable across our 10 stations. But something that I really try to bear in mind and try to make clear whenever I talk about this is because our oldest station, Sky Mountain, went in 2012, our period of record does not exist in a time when Colorado as a whole was not in an overall drought state. So we've had wetter years and drier years within our period, but the time period we've been in as a whole this past decade is considered generally a drought period. So even if I say, yay, 2021 is just like our average, take that with a little bit of a grain of salt. So I did want to, as I'm talking about this year as compared to last year, I wanted to bring in some data from some other sources as well to give a little bit more complete of a picture than these single point measurements that I have at my stations. So I mentioned earlier that there are satellites out there that measure soil moisture data. And again, how accurate they are depends a little bit on where you live and what your terrain looks like, but they can help give kind of this big picture. And I will just quickly explain how the GRACE satellite works because it blows my mind. I don't understand it completely, but it's fascinating to me. It's essentially 2 satellites, and their distance apart is related to the pull of gravity from the Earth. And they are sensitive enough that gravity pull changes a little bit based on how much water is in the ground. And so that's where the soil moisture data comes from, via many magic science transformations in between. So looking at January of 2021 compared to January of 2022, this satellite data shows us something that matches up with what we might expect considering the weather we've had recently, which is much of Colorado is still really dry, but it's not quite as horrifying out west as it was in 2021 in terms of soil moisture. And this is something that plays out in this very basic drought map that I pulled from the NOAA website, where again, you see 2021 on the left-hand side, exceptional drought in large parts of the state and extreme drought in much of the rest of it. This year, we're still somewhere between abnormally dry and extreme drought, depending on where you live in Colorado. But again, it's not quite as severe at this moment as it was in January of 2021. All that being said, we still should be hoping for deep snowpack because that's going to be really important in keeping the drought less severe. And it's also important to remember that all of our reservoirs are really low and that, again, just courtesy of the fact that the ground doesn't forget a drought, we're starting behind as we get into 2022. So a quick recap of this presentation as a whole, because I've covered a lot of different things. Climate change will have consequences for our water supply in Colorado, including in the Roaring Fork watershed. And I'm going to add to that bullet point because of temperature. Rising temperatures are projected to cause us to have more extreme droughts and lower stream flows going into the future. That being said, the better we understand the water cycle in mountains and its relationship to those rising temperatures, the better we can have projections that are going to be more accurate about what the future might look like, and the better we can prepare for a future that's different from the past we have seen. And soil moisture is going to be an important data set in helping to build that understanding, which is an area that AGCI is hoping to help contribute. So what's next for us in the Roaring Fork Observation Network? We intend to keep collecting data. I mentioned at the very beginning, this is a long-term research program. If all goes well, if we keep getting funded and so forth and so on, we will hopefully have a decades-long data record down the line. That data then needs to be used to make informed decisions. So this graphic just shows all the numerous different ways that people look at hydrology in the mountains and think about what the data gaps are and what are the data sources we need. And I want to say that make informed decisions is something that then moves out of the research domain and also involves the resource management domain. And I want to give a shout out to the counties and the cities and the members of the public in the Roaring Fork watershed who are so interested in and engaged with trying to have science to back up the decisions we make. And so that leads to my final point is all of this data really ends up being useless if it just sits on a shelf. So it is a major goal for us to be working with partners both within our watershed and across other watersheds to figure out what are the questions that need to be answered, how can we help supply the data needed, and how can we help responsible and sustainable decision making. So on the right-hand side of this slide, it's just a list of some of the many partners that we have worked with. And I would like to say thank you to all of them for the various ways that they do support this program. If you are thinking you're really excited about this, first of all, my data is for everybody. So if you would like to access this data, whether you're a member of the public who just wants to see what's happening up on the mountain behind your house because you noticed on the map there's a station there, or whether you're a researcher who says, gosh, I would like to dig into and play with this data, please reach out to me. There are various different ways that you can get at our information that I'm happy to share. So here's my contact information. And I'll also say, aside from data, there are other ways that you can engage with this program if you're interested. We do have summer internship programs, and it's really a great opportunity for a student, whether they're interested in working with data or whether they want fieldwork experience or whether they want a mix of both. We'll be sending out calls for applicants pretty soon for those, and they are paid, not necessarily always full-time, but they are paid. And I'm also this year planning to really delve into where there are opportunities for citizen scientists to be contributing data as well. So if you're someone who says, gosh, I'd like to go measure the snow in my backyard, I have not yet created protocols, but that is something on the docket. So please let me know if you're interested. So again, another opportunity for questions. And otherwise, that's all I've got to share for now until anyone requests more information.
Elise, thank you so much. That was great. So great. I have some questions, but I'm going to just remind everybody, if you have a question, go ahead and type it in the chat box. And Hillary just wanted me to tell you, wonderful presentation. Thank you, Elise. So,
oh, well, thank you.
So I'm not sure if I'm saying this person's name correctly, Malin, regarding the soil hydration data, at what depth?
I'm guessing that maybe this person wants to know what depth we're measuring soil moisture at. And we are measuring it at 2, 8, and 20-inch depths, which is 5, 20, and 50 centimeter depths approximately. And that's some sites around the world go deeper than that, but if you're staying kind of in the shallower soils, that's a pretty standard depth suite across.
Okay. If we didn't answer your question, just drop me another note here and we'll probably have you unmute to just clarify. Sammy is asking, do you have plans for adding any more sites? Actually, can I add to that real quick before you answer that question? Because I had the same question because I noticed in your map that you guys didn't have any soil moisture monitoring stations within the crystal, like the upper crystal. And I'm guessing it's probably because of ease of access, but what we know is that the crystal is like the biggest contributor to water actually in the Roaring Fork as far as all the other tributaries. So yeah, I'm curious too, like, are there plans to put one in the Crystal Valley or any other sites, as Sammy asked?
That's a great question. So our original vision that I want to attribute to John Katzenberger, our organization's co-founder, who was executive director at the time, and he's still with us. He's just in a different position at AGCI now. But he, from the start, had this vision of this is going to be valuable as a network if we can get it to be watershed wide and across the different elevations. And so that was our primary goal in originally thinking about how many stations we wanted. It wasn't so much a specific number as wanting to capture those different elevations. Mm-hmm. At this point in the project, we are running into a manpower issue. So with the exception of when I have interns, typically it's just me who's able to get out in the field plus an intern or plus one of my coworkers who I steal away from their other project for a fun field day because we require having 2 people in the field at any given time. And so managing 10 stations can get to be a lot. And I very much would like to see data up the crystal somewhere. And we also have been talking with Rudai Water and Power Authority about potentially having something up the frying pan. So for those of you who are not familiar with this area, that map Christina showed at the very beginning where there was like the big blue line, that was the Roaring Fork, our big river. And then the other 2 kind of lighter blue lines that were on there were the frying pan and the Crystal River, I think. Is that right, Christina? They're the big tributaries. That's all you need to know.
Sorry, I got distracted for a second because I was reading another question.
Yeah, so the frying pan and the Crystal are 2 big tributaries to the Roaring Fork.
Yes, that's correct.
And so those smaller basins are not yet monitored. And
right.
So the answer to your question is there are not hard plans at the moment, but there are discussions underway as to if we were to add stations, what would be the benefit to the network as a whole? Is this going to be feasible to manage, without some big leaps and bounds? So there are no firm plans, but there are some wobbly ones. How's that?
I like it. I'm going to add one more thing too, or just ask you this. If there are people on this call tonight that have private property up either one of those valleys and are like, I would love to have one of these on my property, like, should they get in touch with you?
Absolutely.
Not guaranteeing that they're going to get one like tomorrow, but like if there are people that are interested, right?
Yes, that's actually really a great point, Christina. So when I'm thinking about adding sites, I'm thinking about what is the value scientifically of adding a site. Definitely the Crystal and the frying pan would have value to be monitoring somewhere up there. And then the other question that comes into my mind is, where could it go? Is this something that we could pair with an existing station? Or like you said, if there's someone who has private property in either of those areas who's willing to have their property shared out to have a station, knowing that in advance would be extremely helpful to me, because then I can think about how feasible it is to have a station up in that area.
Okay. I just want to add that Kathleen and Maddie wanted to tell you that you did a great job and thank you. And then we did have Marlene come back and this is what the clarification was on that former question we had. Elise mentioned that satellite data measured moisture level. At what depth does that satellite detect moisture?
Oh, okay. Yes, that is a good question. So if you go to the NASA website and look at the satellite data, they break it into 2 kind of vague groups. So they have one that is shallow soil moisture. So that's less than 4-inch depth. So that's really kind of just surface. And then they have one they call root zone, which is between 10 and 200 centimeter depths. So I think for that, it's probably like, you couldn't say this is the soil moisture at 8 inches, this is the soil moisture at 20. It's just within that big block that happens beneath the 4-inch depth. That's what the root zone soil moisture measurements would be for the satellites.
Great.
And I should say there's different satellites that measure different soil moisture in different ways. So I'm speaking specifically to the gray satellite with a very, very basic knowledge of this. My knowledge of how the satellite operates is like this.
Oh, I get it. Yeah, I understand that. We could always find somebody to talk about that. Also, we have some great relationships with people that do that work as well. I don't have any other questions for you in the chat box, but I just want to ask you another question. And just a reminder, if you have a question, go ahead and add it in here because we're pretty close to wrapping it up. But please stay on to the very end because I want to tell you about the opportunity that you have and nobody else knows about it yet. So quick question for you. How often do you go to your sites? Maybe you mentioned this and I missed it. I'm sorry. How often do you go to the sites? What kind of maintenance do they need? And like, how much time do you spend at each site? And what does it cost to even like put one site together, just equipment wise, and not necessarily like staffing and all that, but like, how much does all that equipment cost?
Those are all great questions. So I might start with the equipment as that's a pretty simple question. I have not bought one in a couple of years, so my guess is price may have gone up, but about $6,000 to $7,000 was the cost of the station that you see in the picture right now. That I will say is also like the bargain basement kind of equipment that there's different gradations. That cheaper equipment has actually served me really well. I found it to be extremely hardy and reliable, and I've been really happy with it. And it's what makes it, I will say one of the reasons it's cheaper is it's designed to be quote unquote plug and play. So like, I'll stop sharing for a second. The non-sensor end of this piece of equipment, as you can see, kind of looks like an old Wi-Fi jack or an old phone jack. And so I just plug that into the station and the station is set up to know how the smart sensor works. More expensive equipment. So we have stations at Castle Creek and Independence Pass that are a little different because they had to be satellite based. And so they were more expensive. The Castle Creek station cost around $20,000. And part of that is it has additional equipment this station does not have. So that's the one that has the sensor that's measuring radiation balance. It has a wind sensor. It has a snow depth sensor. And like I said, it's satellite based. And it's a little bit more flexible in terms of what you can put in terms of equipment. So for a station that's a cheaper station, I can only put equipment that's compatible with that onset logger box. For my Castle Creek station, I can have a mix of different sensors that are wired in. So some of those sensors are Campbell, who is known for being really high quality, accurate sensors. Some of them are Stevens Water, the main provider. And I can, like I said, mix and match a little bit more. And those sensors are tested to be highly, highly accurate at that more expensive site. So there's a number of reasons we went, and that was also just more expensive because it was a higher elevation station. And so we needed a bigger tower. So it would be up above the snow. And so like just the physical structure it sits on was more expensive. And because it had to be satellite based, we also had to purchase, it looks like a top hat to send out the satellite signal. So there's a number of reasons that site ended up being more expensive. Now you were asking about like just cost of equipment. And I actually always really hate breaking that out from everything else, because if you stick your equipment in the ground and there is no one managing that data and there is no one maintaining that equipment, it's kind of like sunk capital. You're not, if everything functions great and someone wants to come back in 10 years, maybe it's going to be worthwhile, but really the cost of these stations comes in afterward in terms of maintaining it, not just the labor of installing it, but maintaining it year to year. And honestly, a big part of the cost is also just storing the data, making sure it's getting cleaned and shared, and developing the partnerships to make sure it's useful. So there's a lot of expense in running a network beyond once you get your station in the ground. In terms of how often we visit, I always budget in terms of time 2 site visits per year per site. So one of those is just routine check, make sure everything looks good. If there's equipment I know is getting old that I want to replace preemptively, hoping to prevent breaking, that happens in that 1 site visit in the summer. And then The second site visit is, some of my sites only get visited once because they behave. There's always at least one site per year that has a recurrent problem where it's like, I'm getting out there 4 or 5 times. And that's, like I said, that's part of field work. And then additionally, we plan field days if it's a year when we're collecting that data on the vegetation, or we've also done tree surveys at the sites that have trees. Just a basic like mortality and health survey of the trees. So that would be another field day, or at some sites even 2 field days because there are so many trees. And then I will say, usually there's some sites that maybe get an additional visit. Like this particular site, I don't know why, loses its transmissions every January. And it keeps collecting data. And so I just go out there and do a power reset and it sends all the data it's been collecting and reconnects for another year. But there's kind of funny little things like that that happen when you're operating a network.
Yes. So just real quick question from Kathleen. Are you able to tell us where in Castle Creek your testing site is?
Yeah, certainly. It is up the Cooper Basin Road. So it's up above the Lindley Hut, essentially. And that one is on an inholding of public land within the Forest Service land. And as far as these stations go, if you happen to be out hiking and see one, which you'd be pretty far off the trail if that happened, but it's not impossible. And there's 2 of them that are actually visible from roads. You are welcome to go take a look, but please don't touch because you can change things. So, you know, if someone is interested in just going up and looking at the equipment, I don't have a problem with that. But like I said, please don't touch anything.
Nathan, your soil scientist friend down in New Zealand, maybe you guys can connect. And well, actually, Nathan, stay on till the end if it's not in the middle of the night and you have a few minutes, because it'd be fun to talk to you a little bit more. But he wrote a note and he says, I can identify with that, Elise. Yes, it's the ongoing maintenance, troubleshooting, and overall resilience of the monitoring system that involves a lot of work and expense. Totally. And when I asked my question, just to clarify, I didn't mean to make it sound like the 2 don't go together, but I think a lot of times people are surprised at what it even takes to get to this point, you know? And so when we're writing grants or you're looking for funding, you're like, we just need 6 or 7 just for a basic site. And that doesn't even include all of the work that goes along with it. Because it sounds like you could use another coworker to help you with all of this, just with the setup that you have right now. I mean, right? And if you're going to add more sites, you're going to maybe need some more help, it sounds like.
I mean, if an angel donor wanted to fund that, I wouldn't say no. But I mean, it's something where it's like we work around because we are a small organization and because we're not typically the type of organization that would do this. We're not a federal agency. We're not a university. And the reason we got asked is because we don't have a research university that has research sites based up in the Roaring Fork Valley. And so it was a really neat opportunity for us to be able to do something that maybe a nonprofit like us normally wouldn't do. And I will say, it does let us have some sort of fun and creative approaches to things like having extra people. So the internships are fantastic. And I've built relationships with some of our former interns. That there's one now in particular who is working a full-time job elsewhere in the Valley, but has told me, if you want help on weekends, call me up. And we're so grateful for that. And we're also in the process of starting a fellowship program. So we'll hopefully have help on the research side there. So we have some kind of creative ways of being small, but doing outsized work. And in response to your question, Christina, I was actually really glad you asked it that way in terms of like, what's the cost of a physical station? Because a lot of times that conversation actually is the conversation we'll have when someone asks, oh, you know, why don't you put one up the Crystal? We can front this much. You know, we can easily front 6,000 or 7,000. And I do have to kind of step back and say, I no longer am willing to put in stations unless we can identify funding to maintain that station going forward. So I'm glad you brought up that point, because I think it's a really important point in thinking about long-term research.
Yeah, absolutely. So speaking of research, if you don't mind, Elise, I'm going to go ahead and share my screen and let everybody, fill everybody in on what I had mentioned before about what we're going to showcase here in a little bit. Can you see my screen okay? Just want to make sure. Thank you, Elise. Okay, so Just a couple of quick things. So the Roaring Fork Conservancy writes a weekly river and snowpack report. And they go out every Thursday afternoon. If you're not already getting them, I really encourage you to sign up because, in fact, I actually wrote about soils, thirsty soils in our summary, our river report summary from last week. So we like to include as much local data as possible when we're writing these. So that little summary up here, this short paragraph, is we're letting you know what some of the changes are that happened from the last week. So please sign up for that. You can do that through our website. I want to invite you to the 2 more Berkshire Watershed Institutes that are happening in February. Elise had mentioned there are no big universities doing research here in the Roaring Fork Valley. And one of the things drought has been bringing a lot of interesting things into the foray here. It's not just it is dry soils, it is low flows, it is water temperatures that are too warm, which are limiting oxygen for the aquatic organisms. Last summer, it was brought to our attention that there are now what are considered algae blooms happening in alpine lakes. We're talking at 12, 13,000 feet, and this is not common. And so we reached out to an algae specialist who's been studying this for years at Colorado University, and she's actually going to, oh, by the way, our water quality team went out and collected some samples from Lincoln's Lake, Independence Lake, and Lost Man Lake, and sent it to their team, and they identified the algae that's in there. We're going to give you results on that. She's going to talk about why we're seeing so much nutrient enrichment in these algae in alpine lakes. And so please come to that presentation on February 8th. And then another fun presentation on February 15th will be with another researcher from the Sonoran Institute, who's going to talk about what they're doing to restore, what they're doing for restoration in the lower Colorado River in the Delta, because the Colorado River hasn't reached the oceans since the 90s. But there is some water going through there, and there's a ton of people working on restoration there, and he's going to tell us about all of the work that's being done there. And then you all are the first to hear about this Taurus no-till site. So we'll talk a little bit about soil moisture that day, but this is an opportunity for you to actually see an official snow-till site that is monitored and run by the Natural Resources Conservation Service. We will have professional snow surveyors with us on this program. You actually get to dig a snow pit with our educators and their snow scientists. You're actually going to look at the different layers of snow. You're actually going to measure how much water content is in the snow. And then you're actually going to get to see, you can see it in this flyer, this big green tube looking thing. That's the snow-till site. And so they'll explain to all of us, like, how is the density and the water content in snow being measured? Friends, this is limited. We don't have room to fit a bunch of people. We are going to be snowshoeing on McClure Pass in order to get to this site. This is not even on our website yet, just to let you know. So if you are interested, email me today or tomorrow. I'll save you a spot, or what I'll do is I'll let you know as soon as registration goes live so that you can go ahead and register and save yourself a spot. Okay, the Redstone Inn is going to host us for the morning part so we can have a cup of coffee, do a little bit of talking before we go outside and actually do the physical work. And then I do just want to end on this note. We are a nonprofit organization, and we're happy to provide these types of conversations and programs for all of you. We do not charge for most of our programs, which is a pretty unique thing, I would say, for a nonprofit, but that also means that we're fundraising a lot. And so we have an opportunity for you tonight. If you are interested in becoming a member, a friend, or a monthly base flows donor, in as little as $5 a month, we will send you, or you can pick up from our office, our commemorative 25th anniversary mug, and we would be so appreciative. So on this note, I'm going to stop recording this presentation. I'm going to thank you again, Elise, for being here, and I'm going to thank everybody for being here. But I will ask, if you're interested, stay on for a few minutes. I'm hoping Nathan says it's 3 o'clock in the afternoon in New Zealand, so he's not sleepy. And so he'll stay on for a few minutes, but I think it'd be fun to continue this dialogue. I just won't record it. And then for those of you that maybe had some questions, but they were of a more personal nature, you stay on for a few minutes. Elise and I will be here to have this conversation. Okay, so great. Thanks everybody, and have a great night.